students, let us start the new chapter, ellipse. First of all, the ellipse is defined to be the locus of a point whose distances from a fixed point, which is called a focus, and a fixed line also called directrix, or in a constant ratio E, where this E is lying in between 0 and 1, that is 0 less than E less than 1 is called ellipse, and here E is said to be the eccentricity of this ellipse. Now we will derive the equation of the ellipse, which is x square by a square plus y square by b square is equals to 1 in its standard form. Let us derive the equation of the ellipse in its standard form. So this is the diagram for the ellipse. So here S is the focus, L equals to 0 with the directrix, and here M comma Z are the projections of P. And what is this point P? P is any point on the ellipse. And N is the projection, or simply we can say perpendicular or normal. N is the projection of P on SZ. SZ, if we extend, then it is the x-axis. C is the midpoint of AZ. Let us take C as the origin, and the line which is passing through this C and perpendicular to this extended line CZ is called the x-axis. So let us write all these points that we have discussed here. Let S be the focus, L equals to 0 be the directrix, focus means it is a fixed point, this is a fixed line, and E be the eccentricity. Let P be any point on the ellipse. Let M comma Z be the projections of P on the directrix. L equals to 0. And N be the projection of this, N be the projection of P on SZ. Projection of P on SZ. Now extend CZ. Extend CZ as x-axis. Let C 0 0 be the origin. C 0 0 be the origin, and C be the midpoint of A dash. A dash midpoint is C. Let the line which is passing through C and perpendicular to x-axis, extended line CZ, and perpendicular to extended line CZ as y axis. Let a comma a dash divides sz in the ratio e is to 1. A comma az divides sz in the ratio e is to 1. A internally and a dash externally. E dash e is to 1 internally and externally respectively. So this is the description of what we have mentioned in the diagram. Since C is the midpoint of A dash, so CA is equals to CA dash is equals to, I'll take A. Therefore, this A becomes A comma 0. This is minus A comma 0. Now, since A comma A dash lie on the conic. What is the conic here? Ellipse. Since A comma A dash lie on a conic, we can apply the definition. What is the definition of a conic? For a point to lie on the conic, its distance from a fixed point SA by ratio its distance from a fixed line AZ is equals to the eccentricity E. Since A comma A dash lie on the ellipse, by definition its distance from a fixed point SA by its distance from a fixed line, that is directrix, is equals to E. From this, SA is equals to EAZ. This is 1. Likewise, A dash is also a point on the same conic, which is ellipse. Its distance from a fixed point SA dash by A dash Z is equals to E. So here one side we are taking into consideration. From this, SA dash is equals to E A dash Z. This is second. Now our intention is to find out the distance between the center to the focus and center to the directrix. For this, I will add 1 and 2 and subtract 1 and 2. So 1 plus 2 gives rise to SA plus SA dash is equals to EAZ plus EA dash Z. Take E in common, then this is AZ plus this is A dash Z. So this is equals to SA plus SA dash. SA plus SA dash is total AA dash only. This is equals to E into whatever the operations that we are going to take from now onwards. I will take C as the basis. So what I mean to say is, this AZ can be written as total CZ minus CA. Total CZ minus CA is AZ only. So CZ minus CA plus A dash Z is CA dash plus CZ. CA dash plus CZ, and here A dash is nothing but CA plus CA dash, CA plus CA dash total A dash is CA plus CA dash is equals to E into CZ minus what is CA is A plus CA dash is also A plus CZ. So A gets cancelled. Here CA is A and CA dash is A. A plus A is 2A is equals to E into CZ plus CZ is 2CZ. So 2 gets cancelled. Therefore we get A by E is equals to CZ. That means the distance from the center of this ellipse to directrix is A by E. That means this distance is A by E. In the similar way, this is also A by E. Then this is A by E comma 0. This is minus A by E comma 0. To obtain this CS, distance between the center to the focus fixed point, SA and SA dash. You see here, SA dash is this large segment and SA is this. So obviously I will prefer 2 minus 1 rather than 1 minus 2. Why not 1 minus 2? 1 is only SA is this, SA dash is this large amount. So instead of 1 minus 2, I will prefer 2 minus 1. 2 minus 1 gives rise to SA dash minus SA is equals to E into A dash Z minus EAZ. Take E in common, then AZ. This is equals to SA dash can be written as CS plus CA dash. CS plus CA dash minus of SA. This SA can be written as total CA minus CS is equals to E into A dash Z is this large segment. This can be written as CA dash plus CZ. CA dash plus CZ minus of AZ is so subtracting CA from the total CZ. So CZ minus CA. This is equals to CS plus CA dash is A minus of CA. Minus into minus plus CS is equals to E into CA dash is A plus CZ minus CZ. Minus into minus is plus CA and CA is equals to A. This is equals to this minus CZ plus CZ gets cancelled. This plus A minus A gets cancelled. CS plus CS is 2CS is equals to E into A plus A is 2A. 2 gets cancelled. Therefore, CS is equals to AE. That means the distance between the center of the ellipse to the fixed point which is focus is AE. That is this distance. This distance is equals to AE. Obviously this distance is also AE. That means the coordinates is AE comma 0. This is minus AE comma 0. Let Px1 y1 be any point on the locus of the ellipse. So any point on the locus of the ellipse. So Pn is the projection of P on the x-axis CZ. and this n is the projection of P on the directrix L is equals to 0. So since P is also seemed to be a point on the ellipse, like A and A dash, we have applied the definition. We can also apply the same definition for this P as well, since P is lying on the ellipse. Since P lies on the ellipse, so its distance from focus SP by its distance from a fixed line PM is equals to E. From this, SP is equals to EPM. So SP square is equals to E square PM square. What is SP? Now SP is equals to S is AE comma 0, P is x1 y1. So the distance formula, the distance between the 2 points, this is x1 minus AE whole square plus y1 minus 0 whole square. So SP square, SP is square root of. So SP square is square and root gets cancelled. So now PM. What is PM here? PM is equals to NZ, because here PMZN is a rectangle. Why? Because this is perpendicular, this is 90 degrees and this is 90 degrees. This is Z is the projection or perpendicular of S on the directrix L equals to 0. Therefore, this is 90, this is 90 and this is 90. This is obviously 90. Therefore, this is a rectangle and this NZ in rectangle opposite sides are equal. So therefore NZ is nothing but PM is nothing but NZ. So PM can be written as NZ and this NZ can be written as total subtracting CN from CZ. This NZ is CZ minus CN. CZ minus CN. What is CZ that we have obtained before? A by E. CZ is A by E minus CN. CN is, since this is Px1 y1, the distance of this N from the origin is at a distance of x1 and this height is y1. Therefore, this CN is x1. So this is PM and PM square is this square. Now SP square equals to EPM square. So SP square is here x1 minus AE whole square plus y1 minus 0 whole square is y1 square is equals to E square. PM square is A by E minus x1 whole square. This is equals to A minus B whole square x1 square plus A square E square minus 2A E x1 plus y1 square is equals to E square into, this is A minus B whole square, A square by E square plus x1 square minus 2A by E x1. This is equals to x1 square plus A square E square minus 2AE x1 plus y1 square is equals to E square into A square by E square is E square gets cancelled. We are left with A square plus E square x1 square minus E square into 2A by E x1. E in this it will be cancelled E times. So minus 2A E x1. So minus 2A E x1 minus 2A x1 on both the sides gets cancelled. So this is equals to, this is x1 square, This is e square x1 square on transposing minus e square x1 square. Take x1 square in common, then 1 minus e square plus y1 square is equals to, here this is a square, this is plus a square e square, on transposing on to another side it is minus a square e square. Take a square in common, then it is 1 minus e square. From this, divide a square into 1 minus e square on both the sides. Then we will get x1 square into 1 minus e square by a square into 1 minus e square. 1 minus e square, 1 minus e square gets cancelled. We are left with x1 square by a square plus y1 square by a square into 1 minus e square is equals to 1. Since eccentricity E is lying in between 0 and 1, because eccentricity E is less than 1 for ellipse, E is greater than 1 for hyperbola, E is equals to 1 for parabola. So then 1 minus e square is greater than 0. If you take E is equals to, for example, 1 by 2, which is less than 1, so 1 by 2 whole square is 1 by 4. 1 minus 1 by 4 is 3 by 4. 3 into 1 by 4, 3 into 0.25. This is 0.75 is obviously greater than 0. And multiple is greater than a square into 0, which is 0. There exists a positive real number. I will take a greater than b, such that this b square equals to a square into 1 minus a square. Then x1 square plus a square plus x1 square by a square plus y1 square by a square into 1 minus e square is b. So this is b square equals to 1. Therefore, the locus of p x1 comma y1 is x square by a square plus y square by b square is equals to 1, provided b square equals to a square into 1 minus e square is the required equation of the ellipse. The ellipse is said to be in its standard form if and only if the center is at the origin. What is center? The chord passing through this C is bisected by this C, then this C is called the center of the ellipse. This center is the point of intersection of coordinate axis, which are the axis of symmetry. So C is the center of the ellipse. Here C is the center of the ellipse, and S comma S dash, or S is the focus, where S and S dash are plural, more than one, foci or foci. S comma S dash are foci or foci. Next, Z comma Z dash are the foot of the directrices. Z comma Z dash are the foot of the directrices, and A comma A dash, A is the vertex. What is the definition of a vertex? The point of intersection of the ellipse and the principal axis. So what is A? A is the point of intersection of this ellipse and the principal axis, x-axis. So x-axis is this and ellipsis is this. Both are intersecting at this point. Therefore, A is said to be the vertex, where A comma A dash are said to be the vertices. A comma A dash are said to be the vertices of the ellipse. And here B comma B dash. So here A dash is said to be the major axis. A dash is called the major axis and BB dash. BB dash is called the minor axis because here A is greater than B. So this is A and this is B. So A is greater than B. Note. So A dash, which is equals to A dash is nothing but CA plus CA dash. CA is A and CA dash is also A. So this is 2A. Therefore, length of this is major axis and this is minor axis. Length of the major axis is 2A and BB dash, this is B and this is also B. B plus B, 2B. Length of the minor axis. Length of the minor axis is 2B. Now, distance between the vertices. Now, the distance between the foci. Distance between the foci is SS dash. What is SS dash? CS plus CS dash. CS is AE, CS dash is AE. So 2AE. Distance between the directrices is ZZ dash. ZZ dash is nothing but CZ plus CZ dash. CZ is A by E, CZ dash is A by E. A by E plus A by E, 2A by E. So, likewise, length of the semi-major axis is 2A by 2A. Length of the semi-minor axis is B. So, length of the next. What is the condition? The condition here is B square equals to A square into 1 minus E square, and where eccentricity E is equals to square root of A square minus B square by A square. So, bigger minus smaller, because A is the length of the major axis and B is minor axis. So, A square minus B square by A square. How did we get this? So, from this. So, B square equals to A square into 1 A square minus A square E square. So, from this, A square E square equals to A square minus B square. So, from this, E square equals to A square minus B square by A square. Therefore, E is equals to square root of A square minus B square by A square. This is the eccentricity. Let us define some terms in this ellipse. Chord. The line segment joining the 2 points on the ellipse is called a chord. That means this is our ellipse, this is our ellipse, and this is the line segment joining the 2 points of the ellipse. Therefore, this is called the chord. Focal chord. the chord which is passing through the focus of the ellipse is called focal chord. This is the ellipse, for example, then, and this is the focus. So this is called, this line is a chord because this is the line joining the 2 points of the ellipse and it is passing through the focus. Therefore, it is called the focal chord. And now latus rectum. The focal chord which is perpendicular to the axis. What is axis? The major axis. Is called the latus rectum. That is, this is our ellipse and this is the principal axis, that is the major axis. This is S. Now this line is the chord passing through this focus, therefore it is focal chord, and this focal chord is perpendicular to the principal axis which is a major axis. So therefore this line is called the latus rectum. The length of the latus rectum of this ellipse x square by a square plus y square by b square equals to 1, where a is greater than b. This is greater than this. This is a and this is b. Is 2b square by a. How? We have already seen that the coordinates of S is a, e, comma 0. Then the coordinates of what is L, L dash? L, L dash is a line which is perpendicular to the major axis and passing through the focus. This is the latus rectum. L, L dash is the latus rectum. L comma L dash are the extremities or the ends of this latus rectum, and since this is perpendicular to this x-axis, this is AE. The coordinates of the x is AE. This is AE, this is AE, and this is also AE. But this height differs. What is the height of this? Which we don't know. Let us take this L. If it is this L, this is minus L. Because this is perpendicular to the x-axis. So if it is AE comma L, this is AE comma minus L. The axis is symmetric. The ellipse is symmetric about x-axis. So now, since L comma L dash lie on the ellipse x square by a square plus y square by b square equals to 1, substituting AE comma plus or minus L. Substituting, since L comma L dash are lying on the ellipse, they must satisfy the ellipse. Substituting AE comma plus or minus L in the equation of the ellipse. That implies x square is AE whole square, a square e square by a square plus y is plus or minus L whole square. This is L square by b square equals to 1. this is equals to a square gets cancelled, e square plus l square by b square equals to 1. So from this, l square by b square is equals to 1 minus e square. This is equals to l square is equals to b square into 1 minus e square. So this is equals to l square is equals to b square into this 1 minus e square can be written as b square is equals to a square into 1 minus e square. That's we have proved. So this is equals to this is 1 minus e square is equals to b square by a square. So therefore this 1 minus e square can be written as b square by a square. This is equals to l square is equals to b square by b power 4 by a square. Therefore L is equals to plus or minus b square by a. Apply this square on transposing on to another side, it is square root. So this is b square by a. This is b square by a whole square. Square root gets cancelled. We got this. Therefore, this is equals to a e comma b square by a. This is a e comma minus b square by a. Therefore, the length of the latus rectum L dash is equals to, this is b square by a and this is b square by a. Totally this is 2b square by a. And the ends of the latus rectum are a comma plus b square by a comma minus b square by a. If p x comma y is any point on the ellipse, x square by a square plus y square by b square equals to 1, standard form of the ellipse, whose foci are s and s dash, then sp plus s dash p is a constant. So this is the ellipse, s comma s dash are the foci, c is the center of the ellipse, p x comma y be any point on the ellipse. So since c is the center of the ellipse, which is the origin, therefore cn is equals to x. Cn is equals to x and this height is y. M comma m dash are the perpendiculars of this p on the directrix L equals to 0 and L dash equals to 0 respectively. Z is the projection of S on the directrix L equals to 0. So foot of the directrix, and Z dash is the foot of the directrix of this S dash on L dash equals to 0. Since P is a point on the conic, we can apply the definition of a conic. Its distance from a fixed point SP by its distance from a fixed line PM is equals to E. From this, SP is equals to EPM. And also its distance from this foci S dash P by its distance from a fixed line directrix PM dash is equals to E. This is S dash P is equals to EPM dash. Now SP plus S dash P is what we have to obtain. This is SP plus S dash P is equals to E into PM plus PM dash. So E into PM is equals to NZ, because PMZN constitute a rectangle. So because this N is the projection of P on the major axis, Z is the foot of the directrix of S on the directrix, M is the normal or projection or perpendicular of this P onto the directrix. Therefore this is 90, this is 90, this is 90, obviously this is 90. So opposite sides are equal. So NZ and PM are equal. So therefore PM can be written as NZ plus PM dash. This PM dash is nothing but NZ dash. This is equals to E into NZ is nothing but, this NZ can be written as CZ minus CN, subtracting CN from this CZ. So CZ minus CN plus NZ dash can be written as CN plus CZ dash. CN plus CZ dash. So this CN gets cancelled. This is equals to SP plus S dash P is equals to E into CZ. So the distance between the center to the directrix is A by E. That's what we have proved in the theorem. Obviously this is also A by E. So therefore CZ is A by E plus CZ dash is also A by E. This is equals to E into A by E, 2A by E. This is E gets cancelled. Therefore SP plus S dash P is equals to 2A, which is a constant. There are several methods of constructing an ellipse. One of these uses the fact that SP plus S dash P is equals to 2A constant directly. The two ends of a string of length 2A are held fixed at the foci S and S dash, and a pencil draws the curve as it is held tight against the string. Hence, an ellipse is the locus of a point, the sum of whose distances from two fixed points is a constant k, provided the distance between the fixed points is less than k.